Greenheck, building value in air.
Welcome back to the shop. Today we're going to cover a Vari-Green control called the HOA or handoff auto. Let's start across the top here. There are 6 terminals on this device. The first terminal we're looking at right here is labeled motor. Now this is where our 2-wire is going to be wired from this device to the motor itself. And we're only going to use common and 0 to 10 volt. So this is sending the speed reference from the HOA to the motor. There is a 24 volt output terminal here, and this is kind of a leftover or a legacy item from earlier generations of Vari-Green motors. So you'll typically not see a wire used in the 24. Our next terminal set is labeled control. Now this again has common, 24, and 0 to 10. This 24 terminal is 24 volts DC output, and it's meant to power other controls, like a Vari-Green constant pressure controller or a Vari-Green remote dial. That's what that 24 volts is for. Common, and then the 0 to 10 volt is an input. We're taking other controls' speed reference, bringing it into the HOA, and when appropriate, it then passes it out to the motor. One more terminal across the top, and that's the auxiliary contact. Anytime this control sees a run command, a 2 volt or better signal, this will change states. There's a common in the middle with a normally open and a normally closed terminal. This is most traditionally used to bring power by others into it and then pass it to a damper actuator when the motor is running. So you tell the fan to run, this changes state, power is passed to the damper actuator, it opens, and then the soft start of the Vari-Green motor brings the fan up to speed. Now these top 3 terminals are the exact same on the Vari-Green HOA as they are on the Vari-Green transformer. So really, they're exactly the same on the top. Where the difference is across the bottom. Let's go there next. So here we have to power this HOA unit, and it'll accept anything from 100 to 277 volts. There's a line 1, a line 2 neutral, and an earth ground. So wherever this box is mounted, whether it's in a mechanical closet, in an enclosure, along with other electronics, we just need to provide power so that this thing will run. Now our next sets of terminals, let's start here. We have our dry auto or dry input terminals. There's an auto and a common. There are 2 common ways of communicating in our industry, and that's using a dry contact or a wet or a voltage contact, right? So the dry ones we just talked about here, what I'm doing is I'm looking for a complete circuit, or I'm looking for continuity. So when I have a complete circuit, you're telling me to run. When I break that circuit, or open a switch, or open a relay, anything that breaks that circuit, you're telling me to stop. So that's the dry side. The next set of terminals is that voltage input. That's that second common type of communication. Anytime I see voltage, you're telling me to run. Anytime you take that voltage away, you're telling me to stop. So let's look at those terminals. So here I can see my voltage input, I have my common, and I have my auto. Now I can use either of these terminals, or I can use both of them at the same time. Both of these are enacting that auto function of our handoff auto. This one simply I'm seeing a difference in voltage, 0 volts on common, say 24 volts from your building management system on auto. Or over here, I'm seeing a contact closure on a time clock, etc. So I am able to use that remote auto input capability to turn this fan on and off. Now just a couple of terminals left. On the end here, we have run status. This again is a dry contact. This contact closes anytime a 2 to 10 volt signal is being sent to the motor. I can use that run status to send information back to a building management system saying, hey, this fan is being told to run right now. I can also send that to a makeup air unit, or I can send it to another HOA. So I can use that as information to say, hey, this fan started, you should start too. Now the last terminal across the bottom, it's labeled fireman's. Now it is a voltage input, so I would use one wire to the fireman's terminal and one wire to the common. This accepts anything from 12 to 120 volts, just like the voltage input. The only difference here is that this fireman's is really just an override. That fireman's terminal is really a second speed or an override. But here's the key. If it's enacted, it takes precedence over all other modes or operations of this device. And that gets us back to a life safety principle. If I'm hooked up to a fire alarm, or if I'm hooked up to a carbon monoxide, carbon dioxide, type alarm system, I want to hit the second speed, whether it's full speed or off. I want to do that, and I don't want the ability for someone to change the state or another device to turn on and change what we've done. So that terminal, when enacted, takes precedence. You have to physically let go or remove voltage from that terminal, and it'll return back to its normal state. So today, we looked at all the different terminals and wiring of the Vari-Green HOA controller. Please come back for the other video, which is going to talk about the different modes and some of the applications for it. Have a great day.